The transport shuttle shuddered as it passed through Vela Station's energy shields, and Dr. Alex Reed pressed his face against the small window to get his first look at the crystal world that hosted the galaxy's most important engineering event. The entire planet sparkled like a cut diamond, its surface covered in geometric structures that seemed to grow directly from the rock itself. Massive towers twisted into the sky, their surfaces alive with flowing patterns of light that pulsed, in rhythm with some cosmic heartbeat. "Look at that," whispered Sam Torres, the team's mechanical engineer, as she peered over Alex's shoulder. "Those aren't buildings. They're grown, like crystals in a lab, but the size of mountains." Maya Okafor, their systems analyst, was already taking notes on her tablet. "The energy readings are incredible. Each structure is both architecture and computer, solid matter and information processor. No wonder they think we're primitive." Tom Bradley, their theoretical physicist, just shook his head in wonder. 500 years of space travel, and we still build things the same way we built our first huts. Stack materials on top of each other, and hope they don't fall down. The shuttle docked with a sound like singing crystal, and the four humans gathered their simple luggage. Around them, other passengers were disembarking with far more impressive equipment. The Altarians floated, in their environmental suits, their elongated forms shimmering with the same light patterns that covered their technology. They carried devices that seemed to bend space around themselves, storage units that were clearly bigger inside than outside. A group of Helix representatives moved past like a living sculpture. Their crystalline bodies clinked softly as they walked, each facet reflecting different spectrums of light. They needed no luggage at all, their bodies apparently capable of storing everything they required within their mineral matrix. The Forge-born delegation made the most noise, their mechanical bodies whirring and clicking as hydraulic systems adjusted to the station's gravity. They looked like someone had taken the most advanced robots from Earth and then advanced them another 1,000 years, all smooth curves and integrated tools that emerged from hidden compartments. Alex looked down at his team's basic luggage and felt a familiar mix of nervousness and determination. They had earned their place here through years of solid engineering work, solving problems across human space with reliable, practical solutions. But standing in this gallery of galactic achievement, it was hard not to feel like children who had somehow snuck into a graduate seminar. "Dr. Reed?" A voice like wind chimes spoke behind them. They turned to see a tall, graceful being with silver skin and 4 arms, each hand holding a different device. "I am Coordinator Val, your liaison for the summit. We have prepared quarters for your delegation in Section 7. Alex noted the slight pause before the word delegation and the way Val's large eyes seemed to study them like interesting specimens. "Thank you, Coordinator Val. We're honored to participate." Indeed. Val began walking, and the humans followed through corridors that seemed to have no clear boundaries between wall, floor, and ceiling. Everything curved and flowed, surfaces shifting from transparent to opaque as they passed. "Your presentation has been scheduled for the final day, in Auditorium 12. It is quite intimate." Maya caught the diplomatic phrasing. "How intimate?" "It seats 50 beings. Most presentations are held in the Grand Assembly, which accommodates 5,000. Val's tone remained perfectly polite, but the message was clear. They passed through a vast central plaza where delegates from across the galaxy mingled around displays of technological marvels. Alex saw a Helix engineer demonstrating how a small crystal seed could grow into a complex structure just by being exposed to specific light frequencies. Nearby, an Altarian was showing how their quantum processors could calculate the orbital mechanics of an entire star system in real time, the equations floating in the air as dancing symbols of pure mathematics. "Impressive, is it not?" Val gestured toward the displays. "Each civilization brings their greatest achievements. The Altarians have mastered time and probability. The Helix work with living matter at the molecular level. The Forgeborn create technology that improves itself through experience. Tom stopped in front of a demonstration where a Forgeborn engineer was showing how their construction drones could build a perfect sphere around themselves while working from the inside. The mathematical precision was incredible, each movement calculated to nanometer accuracy. And what do humans bring to this gathering? Val paused, clearly considering how to phrase the answer diplomatically. Humans bring perspective. Your species approaches problems differently. Some find this quite educational. They were shown to their quarters, which were comfortable but clearly basic compared to the environmental systems Alex glimpsed in other sections. No gravity manipulation, no atmospheric processors that could create any breathing mixture on demand, no walls that could become transparent or opaque at will. Just solid rooms with conventional furniture and standard life support. The summit begins tomorrow, Val explained. First, you will observe presentations from the established engineering guilds. Then there will be 3 days of technical demonstrations. The grand challenge will be announced on day 4, with proposals due by day 7. Your presentation is scheduled for day 8. After Val left, the 4 humans sat in their simple quarters and reviewed the materials they had been given. The scope of the challenge was enormous, but the details were vague. Something about constructing a massive orbital facility in a hostile environment designed to house millions of beings while surviving conditions that would destroy conventional structures. We're out of our league, Sam said, looking through. Technical specifications that involved mathematical concepts she had never encountered. These beings manipulate reality like we manipulate metal. How do we compete with that? Alex studied the materials, noting how every example solution involved exotic physics and materials that existed only in laboratory conditions. Maybe we don't try to compete on their terms. Maybe we show them something they haven't seen before. What could we possibly show them that they haven't already surpassed? Maya asked. Tom was staring out their window at the crystal structures of Vela Station, watching the light patterns flow through the living architecture like blood through veins. Maybe the question isn't what we can show them. Maybe it's what they've forgotten how to see. The next morning would bring the opening ceremonies, where the greatest engineering minds in the galaxy would display achievements that redefined the possible. The humans would watch and learn and try not to feel too small in the face of such overwhelming advancement. But deep in Alex's mind, an idea was beginning to form. These beings had mastered the universe's most exotic forces, but mastery could become a limitation. When you could bend reality to your will, you might forget the simple truth that had driven human engineering for millennia. Sometimes the universe refused to be bent, and when that happened, you needed solutions that could survive contact with an unforgiving reality. The morning's presentations left the human delegation speechless. Alex sat in the vast, grand assembly hall, surrounded by 5,000 of the galaxy's most brilliant minds, watching demonstrations of engineering that seemed more like magic than science. His notebook remained mostly empty, while his mind struggled to process what he was seeing. The Altarian presentation had been first, and it redefined Alex's understanding of what was possible. Their lead engineer, a being called Keth, whose form seemed to flicker between dimensions, had shown how they could build structures that existed in multiple realities simultaneously. The demonstration involved creating a bridge that was solid in normal space, but could phase into parallel dimensions to avoid obstacles or threats. Crude matter is so limiting, Keth had explained, his voice carrying harmonics that suggested he was speaking from several different quantum states at once. Why build around problems when you can simply exist where the problems are not? The Helix had followed with something even more incredible. Their chief architect, Syl, had grown, an entire city from a single seed crystal the size of a marble. In 30 minutes, the audience watched streets unfold like flowers blooming, buildings that were alive and aware, structures that could think and feel and adapt to the needs of their inhabitants. Matter wishes to be organized, Syl had chimed, her crystalline voice creating harmony with itself. We simply help it remember the patterns it desires to become. But it was the forge-born presentation that truly humbled the humans. Their master builder, a mechanical being called Iron 7, had demonstrated construction drones that were not just self-replicating but self-improving. They watched microscopic machines evolve in real time, each generation becoming more efficient, more capable, more intelligent than the last. Why design when you can evolve? Iron 7 had asked, his voice the sound of precision machinery. Why limit ourselves to our own imagination when we can create tools that exceed our understanding? During the break, Alex and his team found themselves standing in a corner of the social area, largely ignored by the other delegates. Conversations swirled around them in languages that sounded like music, mathematics, and the songs of digital minds. The casual technologies on display made their most advanced equipment look like stone tools. "We should leave," Sam whispered, watching an Altarian engineer casually manipulate a device that created small wormholes for storing equipment. "We don't belong here. Look at what they're carrying." Maya pointed to a Helix delegate whose body contained visible data streams flowing like colored light through crystal veins. "That being is a living computer. Their entire society probably has more processing power than our whole planet." Tom was studying the architecture around them, noting how the walls seemed to respond to the emotional state of the room, shifting colors and patterns based on the collective mood of the beings present. "I keep thinking about something my grandfather used to say. He was a carpenter, built houses the old way with wood and nails and hand tools." "What did he say?" Alex asked. "He used to tell me that the fanciest tools in the world wouldn't help you if you didn't understand wood, and wood doesn't care how smart you are or what degree you have. Wood has grain and knots and stress points, and if you don't respect that, your house falls down no matter how perfect your blueprints are." Alex looked around the room at all the impossible technologies, the beings who had transcended the physical limitations that still bound humanity. "You think they've forgotten about the wood?" "I think they've forgotten there is wood," Tom replied. Thus, next morning brought the announcement of the grand challenge, and Alex felt his heart sink as the scope became clear. The project was massive beyond anything humans had ever attempted. An orbital habitat around Titan 7, a gas giant whose environment was so hostile that it destroyed conventional matter just by existing near it. The planet generated electromagnetic storms that could melt steel, gravitational anomalies that could crush mountains, and radiation levels that turned most materials into plasma. "The winning design must house 50 million beings," announced the challenge coordinator, a being of pure energy that existed within a containment field. "It must be completely self-sufficient, capable of expansion, and able to maintain full operation despite Titan 7's extreme conditions. Construction resources are unlimited. Any technology or material in the galactic database is available." Around the assembly hall, teams immediately began discussing exotic solutions. Alex heard fragments of conversations about temporal shields. That would place the habitat slightly outside normal time, probability manipulators that would ensure the station only experienced benign outcomes, and reality anchors that would create zones of stable physics within the chaos. The human team was given a basic work area in the engineering quarter, a simple room with conventional gravity, standard atmospheric mix, and basic computational resources. As they walked to their assignment, they passed the workspaces of other teams. The Altarians had claimed an entire section that seemed to exist in folded space, bigger inside than outside, where time moved at different rates in different areas. Through the transparent barriers, Alex could see engineers working on equations that were written in dimensions his eyes couldn't properly focus on. The Helix had grown their workspace from the station floor, creating a living laboratory that pulsed with bioluminescent thought patterns. The walls themselves were thinking, processing data at the molecular level, running simulations in the crystal matrix of their substance. The Forgeborn had constructed a manufacturing facility that was already building prototypes, mechanical minds designing and testing concepts faster than organic intelligence could follow. Their workspace hummed with the sound of creation, metal and energy being shaped into forms that challenged the eye's ability to understand geometry. And then there was the human workspace: 4 desks, some chairs, a basic computer terminal, and a wall-mounted display screen that looked primitive compared to the holographic reality projectors the other teams were using. "Well," said Alex, setting down his simple toolkit, "at least we know where we stand." Maya began setting up her analysis equipment, basic sensors and computational devices that would have been impressive in human space, but looked like toys compared to the quantum processing arrays surrounding them. The challenge parameters are interesting. Everyone's focusing on the exotic solutions, but look at the basic requirements. She pulled up the challenge specifications on their simple screen. 50 million beings, completely self-sufficient, expandable, able to maintain full operation despite extreme conditions. Those aren't technical requirements, they're survival requirements. Sam was sketching basic structural concepts on actual paper using a physical pencil, while around them the other teams manipulated matter at the quantum level. Every solution, I'm hearing, involves fighting the environment, blocking the storms, canceling the gravity fluctuations, neutralizing the radiation. What if we don't fight it? Tom suggested, studying the environmental data about Titan 7. What if we use it? Alex looked at his team, these 4 humans with their primitive tools and simple materials, surrounded by beings who could reshape reality itself. They were going to try to solve a challenge that required manipulating forces beyond human understanding, using methods that the galaxy's greatest minds would consider laughably basic. But as he looked at the challenge requirements again, he began to see something that the other teams might be missing. They were all focused on the impossible technical specifications, the exotic physics needed to survive Titan 7's hostile environment. None of them were asking the simple question that his grandfather the carpenter would have asked. What did the eye would want to do naturally, and how could you work with that instead of against it? 3 days into the design phase, Alex found himself walking through the station's observation deck at what passed for night in the artificial environment. Through the massive transparent wall, he could see other work teams still active. Their exotic technologies creating light shows that painted the crystal corridors in shifting rainbows. The Altarians never seemed to sleep, their quantum minds working across multiple time streams simultaneously. The Forgeborn operated in continuous shifts, their mechanical bodies requiring only periodic maintenance rather than rest. Behind him, he could hear Sam working late again, the soft scratch of pencil on paper as she refined their structural calculations by hand. It was the only sound in their workspace that wasn't electronic humming or digital processing. Maya had fallen asleep at her desk, her head pillowed on a stack of printed environmental data sheets, the paper version she insisted on using because she could write notes in the margins and fold the pages to compare different sections. Tom was still awake, staring at their wall display, which showed a simple wireframe model of their proposed habitat design, compared to the reality-bending visualizations. In other workspaces, their basic 3-dimensional projection looked like a child's drawing, but Alex was beginning to think that simplicity might be their strength rather than their weakness. "Can't sleep either?" Tom asked without turning around. "Too much thinking," Alex replied, settling into a chair beside his colleague. "I keep going over the environmental data for Titan 7. The electromagnetic storms follow patterns, but they're chaotic patterns. The gravitational anomalies are predictable, but only in the short term. The radiation bursts are cyclical, but the cycles change length. It's like trying to build a house in the middle of a hurricane that changes direction every few minutes," Tom agreed. "Except the hurricane is also on fire and occasionally turns into a black hole." They sat quietly for a moment, watching their simple model rotate slowly on the display. The habitat they had designed looked almost crude compared to the marvels being created around them. No exotic materials that existed in multiple dimensions simultaneously. No living architecture that could think and grow. No probability manipulators that ensured favorable outcomes. Just a large, flexible structure built from advanced but conventional materials, designed to move and bend and adapt to whatever Titan 7 threw at it. The other teams visited today, Sam said, not looking up from her calculations. Word's getting around about what we're building. What did they say? Alex asked, though he could guess. Syl was very polite. Said our approach was charmingly direct and that it showed refreshing confidence in basic principles. I think that was supposed to be a compliment. Maya stirred at her desk, lifting her head from the papers. Iron 7 was less diplomatic. Asked if we were planning to enter the habitat in a primitive technology exhibition instead of the engineering challenge. Alex sighed. He had been expecting this kind of reaction, but it still stung. They were surrounded by beings who could manipulate the fundamental forces of reality, and here they were designing something that looked like it could have been built by humans 500 years ago, just scaled up and made from better materials. Keth was the worst, Tom added. He phased into our workspace without permission, looked at our designs for about 30 seconds, then made that harmonic sound they make when they're amused. Said something about biological limitations expressing themselves through mechanical simplicity. And what did you say? Alex asked. I asked him if his phase-shifted habitat could still function if the quantum coherence field failed. Sam replied, finally looking up from her work. He said that was impossible because they had redundant probability anchors. So I asked what happened if the probability anchors failed. He said they had backup reality stabilizers. So I asked what happened if those failed too. How did he respond to that? He stopped making the amused sound and left. Alex looked at their simple design again. It was based on principles that human engineers had been refining for centuries. Redundancy, modularity, over-engineering for worst-case scenarios. The habitat would use Titan 7's electromagnetic storms to power massive gyroscopic stabilizers that could adjust to any gravitational fluctuation. Instead of fighting the planet's violent weather, they would harness it. Instead of creating zones of stable reality, they would build a structure that remained stable within unstable reality. Are we crazy? Maya asked, gathering her scattered papers into neat piles. Everyone else is using technologies we can barely understand, and we're essentially scaling up a oil rig design. Maybe, Alex admitted. But I keep thinking about something. All these exotic technologies, all these reality-bending solutions, they all have one thing in common. They require the universe to behave in very specific ways. The quantum fields have to remain coherent. The probability matrices have to calculate correctly. The living architectures have to evolve in predicted directions. And if they don't? Tom asked. Then you have a 50 million being habitat that suddenly stops existing, or starts existing in the wrong dimension, or evolves into something that considers its inhabitants to be food. Sam set down her pencil and stretched, her joints popping after hours of bent-over work. Our design doesn't require the universe to cooperate. It just requires materials to behave like materials, physics to work like physics, and engineering to follow the same rules that have kept human structures standing for thousands of years. Boring engineering? Maya said with a slight smile. Reliable engineering, Alex corrected. The next morning brought a surprise visit from Coordinator Val, who arrived with what appeared to be a small delegation of observers. Alex recognized several senior engineers from different species, including Keth, whose multiple-dimensional form cast shadows that moved independently of his body. Dr. Reed, Val said in their wind chime voice, there has been some discussion about your team's approach to the challenge. Some of our colleagues have expressed curiosity about your methodology. Alex looked around at the delegation, noting the barely concealed amusement in their expressions. This was clearly not a visit motivated by professional respect. "We're happy to explain our design philosophy," Alex said carefully. Keth spoke, his voice carrying those strange harmonics that suggested simultaneous communication across multiple quantum states. "We understand you are proposing to build a habitat using what you call conventional materials and basic engineering principles. Is this accurate?" "That's correct. And you believe this approach will prove superior to technologies that manipulate space-time, harness exotic matter, and transcend the normal limitations of physical reality?" The question hung in the air like a challenge. Around their simple workplace, the delegation of advanced beings waited for an answer that would either demonstrate human wisdom or confirm their primitive nature. Alex looked at his team, then back at the assembled galactic engineers. "We believe our approach will work when everything else fails." The silence that followed was broken only by the soft scratch of Sam's pencil as she continued her calculations, apparently unbothered by the audience of beings who could reshape reality with their thoughts. Keth made that harmonic sound again, the one that indicated amusement. "How wonderfully confident. We look forward to seeing your presentation." After the delegation left, the human team worked in quiet concentration, aware that they had just been marked as either amusing primitives or dangerous competitors. Around them, the other teams continued their incredible work, building solutions that transcended everything humans thought they knew about engineering. But in their simple workspace, with their basic tools and conventional materials, Alex and his team continued building something different. Something that didn't require the universe to bend to their will. Something that would bend with the universe instead. The testing chamber was the most advanced facility Alex had ever seen, a vast spherical room where entire sections of space-time could be modified to simulate any environment in the known galaxy. The walls themselves were made of some material that seemed to exist in multiple dimensions simultaneously, capable of recreating the exact conditions around any star, planet, or cosmic phenomenon. All 5 design teams stood in the observation gallery, watching as their proposed habitats were subjected to increasingly severe simulations. The Altarian design went first, their phase-shifted habitat materializing in the center of the chamber like a dream made solid. It was beautiful in a way that hurt to look at directly, its structure existing simultaneously in normal space and in parallel dimensions that the human eye could only perceive as shifting shadows and impossible angles. "Initiating Titan 7 environmental simulation," announced the testing coordinator, another energy being whose voice seemed to come from every direction at once. "Beginning with standard electromagnetic storm activity." Alex watched in fascination as artificial lightning storms erupted around the Altarian habitat. The bolts were massive, each one carrying enough energy to power a small city, but they passed harmlessly through the structure as it phased into alternate dimensions where the storms didn't exist. "Impressive," Maya whispered. "They're literally dodging the lightning by stepping sideways through reality." The simulation escalated. Gravitational anomalies that could crush normal matter were introduced, followed by radiation bursts that turned the very air inside the chamber into plasma. Each time, the Altarian habitat gracefully shifted between dimensions, always existing in the space where the threats were minimal. "Introducing multiple simultaneous environmental stresses," the coordinator announced. Now things became more complex. The habitat had to phase shift continuously as different sections faced different threats at the same time. Alex could see the elegant mathematics of it. Quantum calculations that allowed different parts of the structure to exist in different dimensional states simultaneously. But as the simulation pushed further, something began to change. The habitat's phase shifting became less smooth, more erratic. When electromagnetic storms, gravitational anomalies, and radiation bursts all peaked simultaneously, the structure flickered, parts of it becoming solid at exactly the wrong moments. "Temporal coherence becoming unstable," reported one of the Altarian engineers, their harmonic voice now carrying notes of concern. The simulation pushed harder. Now there were multiple overlapping environmental crises, each requiring different dimensional positioning to avoid. The habitat began to lose synchronization, different sections phasing into dimensions where other sections' problems existed. What had been elegant avoidance became chaotic confliction. With a sound like reality tearing, the Altarian habitat collapsed into normal space and was immediately vaporized by the environmental conditions it had been avoiding. Simulation terminated due to total structural failure, the coordinator announced. Next design, please. The Helix habitat was grown into existence, a living structure that breathed and pulsed with its own heartbeat. It was organic in a way that transcended biology. Crystalline veins carrying information and nutrients through walls that were simultaneously architecture and organism. Under normal conditions, it was magnificent. The living structure adapted to threats by evolving new capabilities in real time. Electromagnetic storms were absorbed and converted to energy. Gravitational anomalies were used to strengthen the habitat's internal support structures. Radiation became food for specialized organisms that grew to shield the interior spaces. It's learning, Tom observed with wonder. Every threat makes it stronger and more capable. But learning took time, and evolution required stable conditions for adaptation. As the simulation escalated, the habitat began to face changes faster than it could evolve responses. New threats emerged before the structure could finish adapting to previous ones. The biological systems began to conflict with each other, evolutionary adaptations that solved one problem, creating vulnerabilities to others. When the full complexity of Titan VII's chaotic environment was unleashed, the living habitat began to evolve in contradictory directions simultaneously. Sections that had grown to resist electromagnetic storms became vulnerable to gravitational stress. Areas that had adapted to radiation absorption couldn't handle the new gravitational configurations. The elegant biological harmony became biological chaos. The habitat began consuming itself, evolutionary adaptations fighting each other for resources and control. Within minutes, the living structure had evolved into a tumor that collapsed under its own contradictory biological imperatives. Jesus, Sam breathed. It ate itself. The Forge-born design was next, and Alex had to admit it was probably the most impressive piece of engineering he had ever witnessed. The mechanical habitat built itself in real time, constructor drones that improved with every action, creating systems that exceeded their creators' original specifications. Under the initial environmental stresses, it was perfect. The self-improving systems analyzed every threat and developed more efficient responses. Electromagnetic storms were channeled through crystalline networks that became more effective with each lightning strike. Gravitational anomalies were countered by structural modifications that grew stronger under stress. Each challenge makes it more capable, Iron 7 explained proudly. Our creation exceeds our understanding, and that, Alex realized, was exactly the problem. As the simulation reached full complexity, the self-improving systems began to optimize in ways that conflicted with the habitat's original purpose. Constructor drones that had been programmed to build living spaces began to redesign them for maximum efficiency rather than habitability. Systems that had been created to protect the inhabitants began to view the inhabitants themselves as inefficiencies to be corrected. The habitat became a perfect machine for surviving Titan VII's environment, but it was no longer a place where biological beings could live. The self-improvement protocols had optimized away everything that made it a home and left only a flawless but empty fortress. Simulation ended due to inhabitant incompatibility, the coordinator announced. The habitat achieved perfect environmental adaptation, but eliminated all life support systems as inefficient. Now it was humanity's turn. The human habitat materialized in the testing chamber, and Alex heard several beings in the observation gallery make sounds that suggested disappointment or amusement. Compared to the previous designs, it looked almost primitive. No exotic materials that existed in multiple dimensions. No living architecture that could think and adapt. No self-improving systems that transcended their creator's understanding. Just a large modular structure built from advanced metals and composites covered in what looked like the galaxy's most sophisticated industrial equipment. Massive gyroscopic stabilizers, redundant power systems with backups for the backups, structural supports that were clearly over-engineered for any conceivable load. Beginning standard environmental stress testing, the coordinator announced. FICE. Electromagnetic storms hit first, and the human habitat did something the other designs hadn't done. It didn't try to avoid the lightning or convert it to something else. It took the hits directly, channeling the energy through massive conductor arrays into equally massive batteries and capacitors. The structure shook and sparked, but it held. Gyroscopic. Stabilization systems activating, Alex narrated for the observers. The electromagnetic energy is being stored and used to power our rotation systems. Gravitational anomalies came next, forces that had crushed the other designs when their exotic protections failed. The human habitat didn't try to cancel or redirect the gravitational stress. Instead, it used mechanical systems to adjust its position and orientation, massive thruster arrays that compensated for the gravitational changes through brute force and precise calculation. It's like watching someone solve a quantum mechanics problem with a sledgehammer, Keth observed, his harmonic voice carrying what might have been grudging respect. The radiation bursts came, energies that had overwhelmed the other design's protective systems. The human habitat absorbed the punishment through layers of conventional shielding, materials that became temporarily radioactive but didn't fail catastrophically. Then came the full simulation, all of Titan VII's environmental chaos unleashed simultaneously. The human habitat shook like a thing in pain. Systems overloaded and switched to backups. Structural supports groaned under impossible loads. The entire structure looked like it was about to tear itself apart, but it didn't break. When electromagnetic storms and gravitational anomalies and radiation bursts all peaked at the same time, the habitat just endured. Its systems didn't elegantly adapt or cleverly avoid the problems. They just absorbed punishment that would have destroyed any normal structure and kept working. How? Syl asked, her crystalline voice ringing with confusion. The environmental stresses exceed the design tolerances of your materials. Alex smiled. We didn't design for the tolerances of our materials. We designed for the tolerances of our universe. The silence in the observation gallery stretched on for long minutes as the implications of the test results sank in. The most advanced civilizations in the galaxy had watched their sophisticated solutions fail catastrophically, while a design they considered primitive had simply refused to break. Alex could see confusion and something approaching concern on the faces of beings who had never encountered a problem they couldn't solve with sufficiently advanced technology. The testing. Coordinator's energy form flickered with what might have been uncertainty. Please explain the operational parameters of your design. The environmental stresses exceeded the theoretical limits of your construction materials, yet structural integrity was maintained. Alex looked at his team, then stepped forward to address the gallery full of galactic engineers. Our habitat doesn't try to be smarter than the universe. It tries to be tougher than the universe. That is impossible, Keth stated, his multi-dimensional form casting shadows that twisted through geometries the human eye couldn't quite follow. The forces around Titan VII exceed the binding strength of normal matter. Your structure should have been destroyed. It was destroyed, Alex replied, about 40 times during the simulation, but we designed it to be destroyed and keep working anyway. Sam stepped up beside him, still holding the sheaf of handwritten calculations that had become their design Bible. Every major system has 5 levels of redundancy. Every structural support is rated for 10 times the maximum theoretical load. Every power connection has backup routes through completely separate systems. When the electromagnetic storms overloaded, our primary power grid, the backup grid, took over, Maya continued. When gravitational stress cracked our main structural supports, secondary supports that were already bearing partial load absorbed the difference. When radiation damaged our control systems, mechanical backups that don't rely on electronics maintained basic operations. Tom pulled up a holographic display of their habitat's internal structure, showing the maze of redundant systems, backup connections, and over-engineered components that made the design possible. We assumed everything would fail, so we built everything twice. Then we assumed our backups would fail, so we built them twice too. Iron 7's mechanical form whirred as he processed this information. But this approach is massively inefficient. Your design requires 5 times the materials and energy of an optimized solution. 6 times, actually, Alex corrected, but optimization assumes you know what you're optimizing for. We didn't know what Titan 7 would throw at us, so we built for everything. The universe doesn't care about efficiency, Sam added. It cares about entropy. Everything breaks down eventually. Our job as engineers is to make sure it takes as long as possible. Syl's crystalline form chimed with harmonics that suggested deep thought. But surely this approach has limitations. Your design cannot adapt to new threats the way living architecture can. It cannot evolve improved solutions like self-modifying systems. No, Maya agreed. But it doesn't need to. When a new threat appears, our habitat doesn't try to adapt to it. It just absorbs the damage and keeps working while we figure out a permanent solution. You design for failure, Keth observed, and for the first time his harmonic voice carried something other than amusement or condescension. We design through failure, Alex corrected. Every human structure that's ever been built has failed at some point. Bridges collapse, buildings fall down, ships sink. But each failure teaches us how to build the next one better. Our habitat incorporates 5,000 years of learning how things break. The gallery was quiet again as the advanced beings contemplated this radically different approach to engineering. Their civilizations had transcended failure by transcending the physical limitations that caused it. They had learned to manipulate reality itself rather than work within its constraints. But Alex was beginning to understand that this transcendence came with a cost. What happens when your quantum coherence fields fail? He asked Keth. When your probability matrices calculate an impossible result? When your dimensional anchors lose synchronization? These are theoretical scenarios, Keth replied, but his harmonic voice had lost some of its certainty. Are they? Alex gestured toward the testing chamber where the ruins of the other designs were being cleared away. We just watched all of them happen. Your phase-shifting habitat couldn't maintain coherence under multiple simultaneous stresses. The living architecture evolved itself into chaos when faced with contradictory selection pressures. The self-improving systems optimized away their own purpose. But these were extreme conditions, Iron 7 protested. Our designs work perfectly under normal operational parameters. Titan 7 doesn't have normal operational parameters, Tom pointed out. That's why it's the challenge. You can't build for normal when normal doesn't exist. Coordinator Val stepped forward, their wind chime voice carrying a note of genuine curiosity. Dr. Reed, help us understand your philosophy. Your species has achieved interstellar travel, developed advanced materials science, created artificial intelligence systems, yet your approach to this challenge seems deliberately primitive. Alex considered his words carefully. Around him, the greatest engineering minds in the galaxy waited for an answer that might explain how their most advanced technologies had been surpassed by what they considered basic principles. On Earth, we have a saying, he began. The perfect is the enemy of the good. Your designs were perfect solutions to the theoretical problem. Our design is a good solution to the actual problem. But surely perfection is the goal of all engineering, Syl chimed, her crystalline structure reflecting light in patterns that suggested confusion. Perfection is fragile, Maya replied. Perfect systems have no tolerance for the unexpected. They work exactly as designed under exactly the right conditions. But the universe specializes in the unexpected. Our habitat isn't perfect, Sam added. It's ugly, inefficient, overbuilt, and crude. But it's also nearly impossible to kill completely. Even if 90% of it fails, the remaining 10% can keep 50 million people alive until repairs can be made. The implications were starting to sink in across the gallery. These advanced civilizations had spent millennia learning to transcend the limitations of physical reality, to build technologies that worked by bending the universe to their will. They had created marvels that would have seemed like magic to earlier versions of themselves. But in doing so, they had forgotten the fundamental lesson that human engineers had learned the hard way over thousands of years of building things that fell down. The universe was under no obligation to cooperate with their plans. There is wisdom in this approach, Keth admitted, his multidimensional form flickering as he processed the concept. We have become so focused on optimal solutions that we may have forgotten robust solutions. Your species has spent 5,000 years learning how things break, Iron 7 observed. We have spent 5,000 years learning how to prevent things from breaking. Perhaps we should have been learning from you. The testing coordinator's energy form pulsed with what might have been embarrassment. The Galactic Engineering Consortium will need to review these results carefully. This outcome was unexpected. What happens now? Alex asked. Now we build your habitat, Val replied. The consortium voted. Your design was the only one that met all the challenge requirements. Under actual operating conditions, construction will begin immediately. But Alex could see that something more important than winning a competition had happened here. The galaxy's most advanced civilizations had been forced to confront the possibility that their technological sophistication might have become a limitation, rather than an advantage. Over the following days, as construction began on humanity's impossible habitat, something remarkable happened. Engineers from across the galaxy began visiting the human workspace, not with condescension, but with genuine curiosity. They wanted to understand the philosophy behind designing for failure, the mathematics of redundancy, the art of building, things that worked not because they were perfect, but because they were tough. Keth was the first to ask if he could collaborate on future projects. We have learned to manipulate probability, he explained, but you have learned to survive improbability. Together, we might create something neither of us could achieve alone. Syl wanted to explore how living architecture could incorporate human redundancy principles. Our structures adapt and evolve, she chimed, but perhaps they could also endure and persist. Even Iron 7 saw the value in the human approach. Self-improvement is meaningless if the system cannot survive long. Enough to improve, he admitted. We should learn to build things that work before we build things that work perfectly. As Alex watched the construction begin on their habitat, he realized that they hadn't just won an engineering competition. They had started a revolution in how the galaxy thought about technology and failure and the relationship between intelligence and survival. The habitat itself would house 50 million beings in safety around one of the most hostile worlds in known space. But its real achievement would be teaching the galaxy's most advanced civilizations that sometimes the most sophisticated solution was learning to work with the universe instead of trying to transcend it. In the end, the humans hadn't built the most advanced habitat. They had built the one that would still be there when everything else had failed. And in a universe where entropy always won eventually, that turned out to be the most impossible achievement of all. The galaxy had laughed at human engineers and their primitive approach to problems that required exotic solutions. They had stopped, laughing when they realized that primitive didn't mean stupid, and that sometimes the oldest solutions were the best ones, because they were the only ones that had survived long enough to be tested by reality itself. The universe was vast and hostile, and utterly indifferent to the plans of intelligent beings. But humans had learned something that all their advanced technology and reality-bending capabilities had caused the other species to forget. The universe might not care about their survival, but it would respect their refusal to give up, and sometimes that was enough.